Okay, so we have two sections to cover today, 8.4 and 8.5. I want you guys first of all to see why the book divided it up the way it did. So 8.4 covers rhombus, rectangles, and squares. If you look at your notes, the rhombus is a parallelogram, rectangle is a parallelogram, and square is a parallelogram, which means all the criteria that we learned last time on 8.2, 8.3 applies to these three figures. So that whole list of figures, it was red on the sideboard, all of that applies to these three figures. In contrast, 8.5 covers kites and trapezoids, and these are quadrilaterals. Both of these are quadrilaterals, they are not parallelograms. So the criteria we learned last time does not apply to trapezoids and kites. So I want to make sure that that's clear for you. Remember, a quadrilateral is just a four-sided figure. A parallelogram is a four-sided figure that has a lot more characteristics to it. So that's why they divided it up this way. So let's start with 8.4. So for a rhombus, some of these characteristics are definitions, theorems, some corollaries. I just simplified it for you. These are the ones that I want you to know. So a rhombus, it's a parallelogram with four congruent sides. Again, because it's called a parallelogram, all the criteria we already learned still applies to this. Four sides are congruent. The diagonals are perpendicular. This is going to be important for your project as you're looking for shapes to fill your robot. Diagonals bisect a pair of opposite angles, so be careful that you understand what that means. We already know that the diagonals bisect each other because it's a parallelogram. We know that the diagonals are perpendicular, and they also bisect a pair of opposite angles. So what that means is this black diagonal splits this red angle exactly in half, and it splits this angle exactly in half. This diagonal splits this angle in half and splits this angle in half. So for a rhombus, it has lots going on with the diagonals. It splits the angles in half, it's perpendicular, and it bisects each other. For a rectangle, again, it has a parallelogram, so it fits all the criteria that we learned last time. It has four right angles, and the diagonals are congruent, which means from A to C is the same length as from D to B. A square, again, parallelogram with four congruent sides and four right angles. That's pretty self-explanatory. You guys are pretty familiar with a square, but be careful that you understand all the criteria that are all the characteristics of squares. It says it's a rhombus and a rectangle. So what that means is we already know that it has right angles because it's here. We don't know that the diagonals are congruent. So by calling it a rectangle, we know that it fits this criteria. It's also a rhombus. So looking back over here, we already know the sides are congruent because of this first part of our definition. But being that it's a rhombus, its diagonals are perpendicular and the diagonals bisect each pair of opposite angles. So there is lots going on with squares, but be careful that you don't think that a square is going to fit all the criteria of your project, because it won't. There's a lot of specifics in there where a square won't work. So just make sure you're reading those very carefully. Look at example 1. So it says WXYZ is a square. Anytime they don't give you a picture, make sure you draw one. It may or may not be helpful, but most of the time will be. So we have a square. We know that it has four sides congruent, and it's called WXYZ. And they're telling us that WX is 1 minus 10x, and YZ is 14 plus 3x. They're asking us to find the length of XY. And because it's a square, we know all the sides are the same. So if I can figure out what x is, the variable x, I can plug it into either of these expressions and figure out that length. And all the lengths are going to be the same. So what would be the equation I'm going to use to set this up so that I can figure out what x is?
1 minus 10x equals 14 plus 3x.
Yep. 1 minus 10x equals 14 plus 3x. I'm setting them equal to each other because we know the lengths are the same. I'm going to move my 10x by adding, so that gives me 13x on the right. But I subtract 14 and put it on the left, which gives me negative 13. And divide both sides by 13, and I get negative 1 for the value of x. So be careful that we had a problem not long ago where we got a negative answer, and I said always double check your variable to see if it makes sense. This actually does make sense, and we're going to find that out by finding out what xy is. We can plug it into either of these expressions to find out that length, because again, it's a square. But when we plug this in, -10 times -1 is +10. So 1 plus 10, the length is 11. So you always want to double check, and this is a good example that not all negatives are thrown out. This actually does work because of the setup of the expression. So I want you to see that not only does that negative work, but also that that length is 11. So to answer the question, xy is 11. Look at example 2. It says classify the quadrilateral. How can we name it? Any ideas?
A rhombus.
What are you going to name it?
Rhombus,
Why?
because all four sides are.
Good. All four sides are congruent. It can't be a square because a square would have 4 right angles and it clearly does not. So the most specific name that we can give this is a rhombus. The next thing we need to do is find x and y. Let's start with the easy one. Because it's a rhombus, we know that the opposite sides are congruent, which means we can set 4x plus 17 equal to 8x minus 3. We're just asked to find x, we don't have to plug it back in. When I subtract 4x, I get 4x on this side. I add 3, I get 20 on this side. Divide by 4, we get 5. How do I find y? What would my equation be for y? Hold on. Anybody tell me an equation for y? Go ahead.
7y minus 5 plus 180 equals 180.
Good. And these two angles are consecutive, they're next to each other. Remember we learned this last time, consecutive angles are supplementary. Big mistake would be to set these equal to each other. They're not equal, they're supplementary. So be really careful. 7y minus 5 plus 108 equals 180. So again, they're consecutive, they're supplementary. So when I consolidate here, we get 7y plus 103 equals 180. Subtract 103 on both sides. And then divide by 7, we get y equals 11. Okay, moving on to 8.5 with kites and trapezoids. So again, moving on to a new section. This section is not parallelograms. These are just quadrilaterals. Quadrilaterals are just 4-sided shapes, and parallelograms are a lot more specific with a lot more characteristics. So a trapezoid says it's a quadrilateral with exactly one pair of parallel sides. That exactly is important. That does not mean that you can have two. One pair of parallel sides. And there's a couple ways that a trapezoid can look. The sides that are parallel are called bases. The sides that are not parallel are called legs. So these are the legs, these are the bases. So the bases are the ones that are parallel. The mid-segment connects the midpoints of the legs. So here's my legs. I'm taking the midpoint of the two legs and connecting them. This black line is called the mid-segment. By naming it as mid-segment, I know that this is a midpoint and this is a midpoint. So lots of vocabulary for this. An isosceles trapezoid, the legs are congruent. So it's still a trapezoid, but the legs are the same length. So you still have one set of parallel lines. It's just that the legs are congruent. They're not always congruent, as you can see in this picture. This one's a specific kind of trapezoid. And if you remember an isosceles triangle having two sides congruent, this is a similar idea and an easy way to remember it. So theorems, taking this a step further, if you know that it's an isosceles trapezoid, we know that these two legs are the same. Because the legs are the same, these base angles will be the same. And this goes vice versa. If I know that the base angles are congruent, I can say the legs are congruent and label it as isosceles. With its isosceles, we have the diagonals as congruent. Now be careful, the diagonals being congruent is not one of those characteristics that we talked about last time. We said that the diagonals bisect each other. Bisect each other means they divide each other in half. That's not the case, and I kind of drew a specific one here. hopefully you can see that this is a trapezoid. And when I drew these diagonals, those diagonals do not cut each other exactly in half. But they will be the same length. So you have to make sure you see how those are different. Mid-segment of a trapezoid, there's two ideas. It's parallel to the two bases. Remember, the bases are the ones that are parallel. The mid-segment is going to be parallel to those bases. And to find the length of that mid-segment, you average the bases. So AB plus DC, those lengths, you add those two and divide by 2, that gives you the length of that mid-segment. So the mid-segment is the average of the bases. For a kite, again, it's a quadrilateral. It's not a parallelogram. It's a four-sided figure. Be really careful with this criteria because it's a little bit tricky. It says with two pairs of consecutive sides, congruent, but opposite sides are not. Consecutive means next to each other. So you guys have an idea of what a kite looks like. Well, these two lengths are the same. They're consecutive. They're next to each other. These two are consecutive and next to each other and the same length. But opposite sides are not congruent. These sides are not congruent. These are congruent. These are congruent. That's much more specific than what we've looked at before where opposite sides are congruent. This is saying opposite sides are not congruent. So that's what makes it look like a kite. A kite has diagonals perpendicular. This is one of the few that's the case for. And it has exactly one pair of opposite angles. So again, when you look at a kite, these two angles, the top and the bottom, are not going to be the same measurement, but the one side to side will be the same measurement. Exactly one set. Not more, not less, exactly one. Okay, let's look at some examples. So the first one, it says find x. You can see that this is a mid-segment up the middle because of the markings. This is clearly a midpoint because we have congruent segments. Congruent segments, that means that this is a mid-segment. So we can use that formula that I told you a few minutes ago. You average these two bases, and that will give you the length of the mid-segment. So we're going to set this up as 43 plus 4x divide by 2, and that will give me 32 as my answer. So this plus this divided by 2 gives me this. First thing I'm going to do is multiply by 2 to get that 2 out of the denominator. Oh, 43, I meant 4x. Let's subtract 43 from both sides. And then when I divide by 4, I get 5.25. And I was asked to find x, and I found x. So anytime I give you formulas, remember, sometimes it can be very simple where it gives you these two, and you just simply have to find that mid-segment. But you have to be able to use that formula no matter what's given to you, and this is a perfect example of that. The last one, we are asked to find the perimeter of the kite. So we know it's a kite. And going back to several years ago when you learned how to do perimeter, we need to add all of these outside lengths of the kite to find the perimeter. Any ideas how to start this? What do you think? Give me a wild guess. Could be. So we know that our diagonals are perpendicular, right? I see 4 right triangles that we spent a lot of time learning about right triangles. Let's kind of divide this up into 2 equal pieces, or pieces, so to speak. So this first one looks like this. I need to find this. Have we ever studied triangles that have 2 lengths the same and maybe have some special rules?
45, 90.
Exactly. You could do the Pythagorean theorem, but those shortcuts are just that, shortcuts. So what do I do to a leg to find the hypotenuse? Good. Look how fast that is. The leg is 5. If I know that rule of 45, 45, 90, I can just multiply by the square root of 2. Look, I'm done. Nothing wrong with using the Pythagorean theorem, but this is much faster. So I now know that this side length is 5 square root of 2, and also this one's 5 square root of 2. Also, the benefit of using our 45, 45, 90 rule is that this is an accurate answer. There's no rounding, which is usually better. You don't want to round and lose some of your accuracy. So now let's look at this triangle. So this one kind of looks like this. We have a 5 and a 12. Does anybody recognize that one as a Pythagorean triple? Most people don't. Okay, if you don't, then you have to plug it into the Pythagorean theorem. So 5 squared plus 12 squared equals c squared. Doing this with me? 25 plus 144. When we add these together, I get 169. What do I get when I square root?
13.
Good. So this unknown side is 13. So we now know the sides, and I want to make sure that you guys are comfortable with adding these things together. So going back to basic perimeter kind of problem, I have 5 square root of 2 plus 5 square root of 2 plus 13 and plus 13, because that's how you find perimeter, right? Just adding all the sides. Well, I don't want to do any rounding. I want an accurate answer. When you're adding with radicals, you can add the number in front of it as long as you have the same number under the radical. So in other words, because these both have 2's, I can add those 5's. So you want to think about this very similar to if I had 5x plus 5x, what would this give me?
10x.
Do you see what we did there? We added the 5's and kind of dragged the x with you. Very similar here. So you're going to add the 5's and just keep the square root of 2 with you. So this becomes 10 square root of 2. And then of course adding these together would give you 26. So this is a non-rounded, completely accurate answer for this perimeter. There's no directions that say it has to be answered this way. So if this was a test or a quiz question, I would accept it as a decimal. But I do want you guys to get more comfortable with those radicals.